So first of all, thank you so much for taking your time to attend today's webinar. I hope everyone is doing well. So for those who don't know me, my name is Aman and I'm working as a QA engineer. Over last few years, I'm working extensively with Playwright automation, building automation framework, maintaining regression suites, debugging flaky tests, integrating CI/CD pipelines, and more recently. And recently exploring how artificial intelligence can transform the way we automated software and like we automated software we automate software testing and test cases. So today's session is all about something that has genuinely changed the way I work every single day in testing. And the topic is Playwright with AI and remanaging test automation for the Agentic era. So now, whenever people hear AI in testing, they usually think AI is going to replace automation engineer. I personally don't believe that's true. Instead, I believe AI is becoming one of the most powerful assistant we have ever had. So think about how we used to work 2 years or 3 years ago. Whenever a Jira ticket came in, we would like first read the requirement, understand the feature, inspect the application, write every playwright command manually, debug the script ourselves, and fix the locator, and rerun the test, maintain them after every UI update, and repeat this cycle again and again. So today, many of these repetitive activities can either be automated or like significantly accelerated by AI. So instead of spending hours like writing boilerplate code, we can describe the scenario in plain English and let AI generate the initial implementation. So even more interesting, using technologies like MCP or AI can actually interact with a real browser instead of simply suggesting code. And when we combine Claude Code, Playwright, Jira, Git, and MCP, we begin like moving towards what is called agentic automation. So where AI become an active participant in the automation workflow instead of being like just a chatbot. So before we dive in, I would like to make one thing very clear. The webinar is not about replacing tester. It's about making tester more productive. Throughout this session, I'll show you both advantage and limitation of AI, because understanding both sides is like what make us better engineers. So without taking much time, let's begin. So this is our roadmap for today's session. So I always begin with an agenda because it gives everyone a clear picture of what like where we are heading. So we will go through it we will go through the presentation step by step, and every section build upon the previous one. So first we'll discuss the old way. This is how most QA engineers, including me, used to write Playwright automation before AI become part of our workflow. So we'll understand the traditional development process and identify the pain points. Next, next come enter AI. So this is where things being changing. We'll see how large language model help us to generate test cases, create better selectors, generate test data, and even assist in debugging. Then we'll spend some time with Claude Code. Many of us may already know about Claude and Claude as an AI chatbot, but Claude Code is much more than that. So I'll demonstrate how we can use it in our day-to-day automation work, and then we'll move into more advanced capabilities like agentic workflow. After that, we'll discuss MCP, like model context protocol. Personally, I don't. Personally, I think this is one of the biggest innovation in AI assistant development, and allow AI to like interact with the real tools, like instead of only generating text. So we understand how it works and why it is so powerful. Then we'll connect everything together like Jira, Git, and Playwright MCP. And finally, we'll end with the benefit, challenges, and best practice. Because technology has advantage, but it also has the limitations. So it's important to understand both. So before moving on, I would like to ask a quick question. How many of you are currently using AI in your automation work? Maybe you are using Chat GPT, Claude, GitHub, Copilot, Cursor, or any other tool. You don't have answer a lot, but you think about it. By the end of this today's session, I hope I hope you will leave with several new ideas you can immediately like apply in your own project. So let's get back to few years back, how we used to build like Playwright automation. So before we appreciate what AI offers us today, we need to remember what automation looks like before AI. So let's walk through the traditional automation workflow. So this like we can See, this slide summarize you to traditional life cycle of automation. Although every company has slightly different process, the overall workflow is very similar. So the first step is always understanding the requirement. And automation should never begin with a code. It begins with understanding the business. So typically a QA engineer opens a Jira ticket, read the user story, review the acceptation criteria, and try to understand what exactly application is expected to do. Then handwritten every step, like once we understand the feature, we start writing every locator, every click, every wait, every assertion, every utility method. Everything is written manually. For example, if we have a checkout flow with 50 interactions, we manually write all the 50 steps. This process required a good understanding of Playwright, JavaScript or TypeScript, HTML, CSS selector, accessibility rules, and other application DOM structure as well. So now comes the most frustrating part is like debugging. Sooner or later, every automation engineer encounter failing tests. So sometimes the issue is our script, sometimes it's application, sometimes it's test data, or sometimes it's simply timing. The debugging process can consume a significant amount of development time. Then finally, after the tests are completed, maintenance begin. Many people think writing automation is difficult part, but actually maintaining automation is much harder. Imagine your application receive a UI redesign, any button move, ID change, or any locator change. Suddenly, hundreds of test cases begin failing. So now someone has to interact every failure and update those script manually. This maintenance effort is often the biggest cost of the automation. So I personally experienced this sometimes after a UI release. Dozens of Playwright tests failed not because of the application was broken, but because the UI structure has changed. We ended up with spending more time fixing locators, then writing new automation, and then exactly the problem AI helping us today. So let's look at the actual Playwright example that demonstrate this problem. So now you are looking at the real Playwright test. So don't worry if you are new to Playwright. I'll explain you what I have written over here. So this is our declaration. So this in this particular program here, we are creating a Playwright test name as user can complete checkout. So the page object represent our browser. So everything we do inside the browser, opening page, clicking button, typing into field, is performed through this object. But the main noticeable part over here, this is this locator. The So this is selecting the third button on the page. So at a first glance, it seems okay. But imagine tomorrow another button is added above it. Suddenly this button is no longer the third child. Without changing any business functionality, our automation breaks. Then we think so although this test look relatively small, amazing writing hundred of similar tests across an enterprise application. Each test contains dozens of locators, dozens of assertions, dozens of wait. When a UI change, someone has to maintain all of them manually. This repetitive work is exactly where AI begin providing his its value. So now we have seen now what manual automation look like. The obvious question become, can AI help us to reduce this effort? Let's find out the how AI can help us to reduce this effort. So now that's we have seen what a traditional Playwright test look like, but in this slide you can clearly go through that where AI is actually helping us to getting out from that manual effort. So we can say this is the first challenge we are getting while writing manual automation. Like the first challenge is brittle locator. So this was probably even my biggest frustration when I started working with UI automation. Imagine you have spent several days to writing a stable regression suite. Everything is passing, then the front end team decide to redesign a page. Maybe they change a CSS class, maybe they move a button. The application still work perfectly, nothing is actually broken for the customer, but the next morning your pipeline is completely dead, not because of bugs, because of your selector is no longer valid. So this is the difference between testing functionality and depending too much on the implementation. The more fragile your selector are, the more maintenance your automation requires. So the second challenge is creating the test data. Think about a registration form. You don't just test one name or one email. You need to test with valid emails, invalid emails, spatial character, boundary values, and creating all of this manually take a surprising amount of time. Sometimes writing the test data taking longer than writing the automation itself. And if the business rules change, we have to update all of those data set again. And the third challenge is slow authoring. So let's imagine you received a Jira ticket for end-to-end booking flow. The user log in, search for a trip, add a product, configure pricing, make payment, receive any confirmation. This like single flow could easily contain 50 or like even 100 interactions. Writing every locator, assertion, helper, or any validation manually can easily consume several hours, and that's like assuming everything work on a first attempt, which is like rarely happens. And finally, the maintenance. Many new automation engineers believe writing test is hardest part, but actually maintaining them is much harder. The larger your automation suite become, the more maintenance it required. So now we understand the problem, and the next question is how actually AI help us to solve this. Let's find out. So this slide is like marked the beginning of the completely different way of thinking about automation. So I didn't say AI changed Playwright. Playwright is Playwright, still Playwright. Assertion are still assertions. What changes workflow? Instead of starting with a blank file, we start with an idea. Instead of writing everything, every line or everything ourselves, we collaborate with AI and think of AI as another engineer sitting beside you, and you explain what you want. So this is where things becoming really interesting. AI isn't just generating code anymore, it's helping throughout the entire automation lifecycle. Let's look each and every capability that AI has. So first thing is like we can say natural language. So the first natural language is to code, like test code is just basically imagine you receive a Jira ticket. So instead of immediately opening BS code and writing automation from scratch, we can simply describe the scenario. For example, create a pre test to log into admin, create a customer, verify the confirmation message, and log out. Within seconds, AI generate the initial pre test. Now, is it perfect? Not always, but instead of starting from zero, we are starting from 80%. That's a huge productivity improvement. The second capability AI has is to like this is one of my favorite, like self-healing selectors. Earlier we discussed how small DOM change cause our automation to fail. AI can like often recognize that HTML change, the user interaction did not like instant like immediately find that. But AI can suggest a better locator or identify the new element automatically. Next come with like synthetic test data. Suppose I need 50 different customer record. Instead of manually creating all of test data, I simply ask AI, for example, generate 10 valid user, 5 invalid user, and 5 edge case user for checkout testing. Within second the data is ready. This save an incredible amount of like preparation time. Next, the visual regression. AI can help the we can say diagnose meaningful like visual change from harmless noise. So instead of reviewing hundreds of screenshots manually, we focus only the changes that actually matters. Finally, one of the most useful capabilities is failure analysis. So imagine your Playwright test fails during the night, and today AI can analyze those failures and suggest likely causes within seconds. Again, it's not replacing debugging, it's making debugging significantly faster. So in my own work, I often like copied Playwright errors into the Claude Code, and instead of spending like 20 minutes reading stack trace, Claude immediately pointing out which locator has changed or which assertion was incorrect. That saved like we can say a lot of amount of time to investigate for the failure. So this all sounds like great, but what does it actually look like? Let's compare the traditional approach with an AI assistant workflow. So now we have like this is probably we can say my favorite comparison in the presentation, because it like clearly shows how our workflow change. Notice the both example achieving the same business logic, the application behave exactly same. The difference is how we write automation. So Let's start with the left side. So this is the traditional approach. Notice this selector. We are selecting an element based on its position, and we are using a fixed timeout. These two patterns were, like we can say, extremely common a few years ago. They work, but they are fragile. If the layout change, the automation break. Same in the right side. So instead of writing everything ourselves, we simply provide a prompt, something like add a step to save the batch and verify the success stories. AI generate the implementation within seconds. And you have noticed something, the locator get by road. So this is much closer to how user actually interact with the application. User don't think click on the third button, they think click on the save button. So role based locators are usually much more reliable and easier to understand. So the biggest benefit isn't the AI write code faster. The biggest benefit is AI often generate brittle and like we can say better initial code by following modern playwright test practice. So far we have discussed the theory. So now I would like to show some example real world automation project to show you the real difference. So far we have like discussed only the theoretical part. So the next in next slides we are going to discuss the like real base scenarios that almost every automation engineer encounters sooner or later. So in the first example, what we are going to discuss about the page object model, and in the second example we will see the example for the automating a rich text editor. So now let's look at our first this one. So this is something almost every automation engineer has worked on a same point, like a checkout flow. And this is we can take any example like e-commerce, any e-commerce like website like Amazon, Flipkart, or any booking platform. A user doesn't just click one button, they go through with multiple steps. Now imagine automating all those steps in a single playwright file very quickly. That file become hundreds of long line codes. It's difficult to read, difficult to debug, and even more difficult to maintain. That's exactly why we use something called a praise object method. So look at this class like checkout page. So think page object method as a representation of we can say one page in your application. Instead of writing locator everywhere in our test, we collect everything related to the checkout page inside one class. This make our code cleaner and much easier to maintain. And the we can say the this receive, like we can say remember the page object is our browser. Every click, every keyboard input, every navigation happen throughout this object. Instead of passing it around everywhere, we store it inside the class so every method can use it. So like we have 3 points mentioned over here. So the first point is saying that the flat selector first. So when we begin like automating a new feature, we don't immediately create a complex framework. We usually write a one working playwright test. Once we are confident, then then the workflow we are confident the workflow is stable. We gradually reflect into the other pages or in other test cases. So this approach avoid unnecessary complexity in the beginning. So the second point is saying one class per step. So each page or workflow owns its own locators and actions. This makes debug more easier. If someone if something breaks during payment, I know like exactly which class I need to inspect. And finally, probably the most important message over here on this slide is AI scale off, or like we can say human direct. So today Claude can generate an entire page object structure within seconds. It can create method, constructor, imports, folder structure, and utilities. But AI doesn't know everything. It doesn't understand your and our business rule automatically. It doesn't know which selector your team prefer. It doesn't know if the payment in frame behaved like differently in the production. Those decisions still belongs to us. Think of AI an incredibly fast assistant, not the architect. So that's an example where AI perform exactly well. Now let's look at the another example where AI actually struggle the first time. So this is one of my favorite example because it demonstrates an important lesson. AI is powerful, but it is not a magic. some UI components require human understanding. So many modern application contains rich text editors. For example, Confluence, Notion, Medium, Jira commands, blog editor, even like sometimes mail editors. So when we type into these editors, we are not actually typing into normal text box. We need to like basically we are interacting with something called a continentable element. So we can say notice this locator. So instead of searching for input field, uh, we are locating an element with the attribute like continentable equals to true. This tells the browser that although this element is technically a div, user can type inside it. So this is very different from working on a normal input field. So we can say the first point is something I have personally experienced, where you ask AI to automate a rich text editor. Its first attempt often like assume it's working with a text editor because that's the most common situation. But in many modern applications, there isn't any text editor at all. So what we do, give AI more information. Instead of saying type inside the editor, say type inside the continentable div using keywords event. The more context you provide, the better generation like automation generation become better. And finally, don't expect perfection from the first attempt. Like think of an AI as a collaborating with another engineer. The first version is rarely the final version. You review it, improve it, and ask follow-up question. Like it's gradually refine it. That's the workflow that produce the best results. So I have actually encountered situation where Claude almost write perfect automation, expect one locator. So instead of rewriting everything myself, I simply explained the DOM structure, and Claude immediately corrected the implementation. So the interactive workflow is much faster than starting from scratch. So far we have till now we have discussed focus on the Playwright examples. Now I would like to introduce the AI tool that has completely changed how I write automation every day. So this section is completely dedicated to Claude Code. If Playwright is our automation engineer, Claude Code is our AI engineer partner. So many people think Claude is simply a chatbot, but Claude Code is very different. So we'll begin with the simplest and most practical use cases. Then we'll move for the advanced one. So this slide shows four example how I use Claude Code almost every day. And these aren't advanced AI tricks. These are just practical tasks that save my time for day-to-day automation. So let's start with the first example. Instead of creating a like Playwright file manually, I simply tell Claude, write a Playwright test for login flow. Within seconds, Claude generate a complete Playwright test with a negative locators and negative positive cases, assertions, and navigation and error handling. Is it always perfect? No. But instead of starting from an empty file, I'm starting with a strong first draft. The and second is why this test is flaky. This is probably the problem which I use most. Every automation engineer has flaky test. Instead of reading hundreds of logs lines myself, I simply paste the playwright test or error output into the Claude and ask why this test case is flaky. Very often we can say Claude identify timing problems, incorrect locator, missing wait, or race condition within seconds. The and update this locator. So this is another we can say huge time saver. Suppose the front end team change one button. So instead of manually searching for entire project, I ask Claude to update this locator. This will save we can say Claude find the exact file, update only the required locator, and leave everything else untouched. That we can say this save a lot of time. And last is explain this aspect. So we can say one feature that many teams underestimate. Sometimes we inherit old automation written by someone else, so understanding that code takes hours. So instead we can ask Claude, explain this Playwright specification. Within second is summarize the test, explain the workflow, identify we can say important assertions, and even point out possible improvements. And this makes onboarding much easier for new team members. So far, for me, Claude isn't replacing programming, it's removing repetitive work. Instead of spending time on boilerplate code, I spend time to solving actual testing problem. But everything we discussed so far is only the beginning. So now let's look at what Claude can do at an advanced level. So we are moving beyond simple points. So this is where AI start becoming much more autonomous instead of helping with one task. So it begin managing entire workflow. So the first feature is sub agent. Think of this like assigning work to multiple engineers. One agent writing the playwright test, another review the code, and third generate the documentation. So instead of performing these tasks one after another, AI can divide that work into like specialized responsibilities. Next are hooks. So hooks automatically trigger action after certain event. For example, every time Claude edit a playwright file, it can automatically run and it run the JavaScript or TypeScript compiler, execute playwright test, and immediately tell us if something breaks. This give most instant feedback. So now let's talk about the headless mode. So normally we interact with Claude Code manually, but in CI pipelines, Claude can run automatically, imaging a NIT build. Claude analyze the failure, suggest fixes, generate updated automation, even prepare code change. So that's incredibly powerful for large project. And finally we have custom slash command. So instead of repeatedly typing long prompts, we create reusable commands like example slash gen test. So this could generate a playwright test using your company coding standards. We can use slash review PR that could automatically review a pull request. Slash Jira ticket, this could we can say read the Jira requirement and generate the automation for that ticket. And this make AI like consistent across the entire team. We can use it very easily. So Claude Code involved from being a coding assistant into becoming an intelligent engineer teammate. And this is exactly where the industry is moving now towards this replacing the engineering, but towards giving engineering intelligent collaboration. So uh, so far, we have seen like how AI generate pillar test, explain code, review automation, and help us to debug the feature. Now, I would like to introduce the technology that, in my opinion, is one of the biggest innovation in AI assistant software development. The technology is called MCP, which is like we can say model context protocol. And this is where AI stop being just a chatbot that gives suggestions and start becoming an active participant in the testing process. So before we see how it works with Playwright, let's first understand a like very simple question: what exactly MCP is? So we can say the name model context protocol sound quite technical, but honestly, the concept is actually very simple. Think of MCP as a translator between AI and real software tool, and you can see. The slide shows three components, so let's understand them one by one. So Claude, on the left side we have Claude is responsible for understanding what we are asking. Then we that's where the MCP server come in. Think of MCP server as a translator or an interpreter. And finally we have the real tool. This could be Playwright, it could be Jira, it could be GitHub, or it could be a database. And these are the tools that perform the actual works. The important point is that the work is happening in the real application, not inside the AI model. So uh, we can say, so now that we have understand the concept, let's see what connecting Playwright MCP actually look like. So how we can connect the Playwright MCP. So we are looking the actual configuration. So connecting Playwright MCP is surprisingly very simple. We don't need to write any 100 lines of configuration or anything. This is like small configuration. Tell Claude Desktop that whenever Playwright code actions are required, use this MCP server, and that's all. Behind the screen, MCP server launches Playwright and connected Claude to a real browser. Then we think that why to connect it. So why would we want to do this? Let's we can say we I'll tell you some advantage of connecting MCP. So the first advantage is probably the biggest one. Claude open a real browser session, not a screenshot, not a HTML copied into prompt, an actual browser exactly like the one you and I use every day. Then we have like navigation, click and type. Like Claude can navigate a page, click a button, fill a form, select a drop down, read tables, upload any file. Everything is a normal Playwright script can do. Instead, we manually testing every workflow. Claude can assist in exploring the application. The third capability is very fantastic for debugging. So normally normally when automation fails, we inspect browser console log and network requests to ourselves. But with MCP, Claude can read those logs automatically. Suppose a JavaScript error appears in browser, so Claude immediately sees it. Suppose we can say an API error, return a 500 error. Claude can inspect that too as well. And finally, one of my favorite use cases, exploratory testing. Sometimes we don't even know what we are looking for. We simply want to understand how a feature behaves. So instead of manually clicking through every screen, Claude can interact with the application, observe the workflow, and identify important elements, and even generate a Playwright automation based on what it discovered. So in my personal experience, in one of my recent automation tasks, I needed to automate a complex booking workflow. So instead of manually inspecting every page, I just go to I opened the Claude and explore the I asked Claude to explore the application. It navigates through multiple screens, identify important elements, and generate the first version of my Playwright test. That save a huge amount of initial setup time. So we have seen the Claude interacting with Playwright, but imagine connecting it with our engineering tool as well, where that things becoming very interesting and powerful. So now we have like this. We can see this slide introduce what I call an AI power engineering workflow. So until now we have looked at each tool individually: Jira, Playwright, or Git, Claude, MCP. But the real magic happens when these tools begin working together. So in the next slide, we'll demonstrate we'll see a complete end-to-end application pipeline. So imagine you are working on a project and on Monday morning a new bug is reported. The first step begin is Jira. So someone create a Jira ticket, then check out the total we can say the bug is check out the total of any total amount is showing wrong for the US users. So this is where our journey start. So what it will do, Claude instead of opening the Jira ticket manually, Claude automatically copy the description, copy the screenshot, copy the reproducible steps. Claude retrieve everything directly through the Jira MCP connector, and it actually understand the requirement before we even start writing automation. So next, Claude use Playwright MCP to reduce the issue, and it open the application, perform the same step described in the Jira ticket, or and verify whether the bug is actually exist or not. Then it generates the initial Playwright automation as well, and then alone it can we can say it save a lot of our manual time for investigating the bug and automating the particular steps. Then once the issue is resolved and everything is based automation is passed, it create the PR as well. If we can say if everything is fine, if there is a we can say it can also prepare the implementation commit that changes and change it create a pull request through the Git and GitHub MCP. So imagine how much manual work disappeared here. So instead of switching between 5 different applications, everything become part of we can say continuous workflow. Then finally it we can say after the pull request is created, Claude update the Jira ticket as well. So the status of the Jira ticket can be changed automatically, comments are added, and links to the pull request are also attached. And also QA engineers, product manager, all receive an update information without anyone manually copying and pasting the detail. So this entire process create what we call a closed loop workflow. So we can say there are few meetings, less manual communication, less duplicate work, and much faster feedback. So I personally find this extremely exciting, because this is where AI become much more than a coding assistant. It become part of our engineering process itself. Instead of helping with one isolated task, it assists throughout the entire software development cycle. So So far we have in this presentation we talked how AI help us to generate playwright tests, how Claude Code assist with development, how MCP allow AI to interact with real application, how tools with Jira, Git can interact with a single workflow. So now take a step back and ask ourselves a simple question: what are the actual benefits of using AI in automation? So the first and the most of obvious benefit is faster authoring. So think about how we use start writing automation. We would create a playwright file, write a import, set up the test structure, write locators, write helpers, then start implementing the actual business logic. So today AI can create the initial structure within seconds. And the second benefit is, we can say, self-healing test. So earlier we discussed how a small UI change could break our automation. So with AI assistant automation, identify those changes become more we can say much easier. And we can, like, AI doesn't magically fix every broken test, but it significantly reduce the amount of manual investigation required. And the third benefit is richer test data. So one of the biggest challenge in automation is creating a realistic database. Suppose I'm testing a travel booking application. I don't need one customer. I need customer from different countries, different we can say ages, different booking preference, different inputs, different boundary values. So instead of creating all this manually, AI can generate it almost like instantly. So it could suggest edge cases that we may not have considered ourselves, so that help improve overall quality of test coverage. So next we have faster debugging. Anyone who is worked in automation knows that debugging often takes longer than writing the automation itself. So Playwright provide excellent debugging tools like trace, screenshot videos, and console logs. But analyzing all of them, all of the information, all of the screenshot still take times. So this is where AI become extremely useful. So instead of reading hundreds of lines of logs manually, AI analyze them and highlight the most likely causes of the failure. And the fifth benefit is something I think we have a huge impact on the automation engineering. AI, we can say, lower barrier to entry. So earlier, someone new to Playwright need to learn framework structure, selector, assertions, programming, and debugging techniques and coding standard before becoming productive. So today, AI act like a mentor. A junior engineer can ask question, generate example, understand existing code, and receive like explanation almost instantly. So this doesn't eliminate the need to learn, but it definitely accelerate the learning process. So the final benefit is fewer manual hands-on. So earlier information, we can say, constantly move between Jira, Git, documentation, chat, messages, emails, or test reports. With MCP and AI integration, many of those repetitive activities become automated and status update happen automatically. So if I had summarized all the benefits in one sentence, I would say AI doesn't replace automation engineer. It removes repetitive work so engineers can focus on solving more valuable problems. So now after hearing all these advantages, it might sound like AI solving everything, but it is not true. Like every technology, AI also has some limitation, and understanding those limitations is just as important, and understanding the strategies how we need to use and what challenges you can face. So I personally believe this is like one of the most important slide in the entire presentation. Whenever people discuss AI, they often focus only on the benefits, but as an engineer, we should also understand the risk. So let's go through each and every limitation and risk. So the first is hallucination assertion. So the first challenge is like sometimes AI confidently write assertions for element that doesn't actually exist. For example, it may assume a success message says saved successfully, while the application actually displays change saved. So the code looks correctly, it complies successfully, but the assertion is wrong. That's why we should never blindly trust on generated automation code. The second challenge is junk or unrealistic test data. AI can generate names, address, phone number, or booking details, but sometimes those value doesn't follow real business rules. So maybe a booking date is in past, maybe a phone number has the wrong we can say input, maybe a customer age validate business requirement. If we don't review the test data, our automation may fail, or we can say that this is sometimes a reason to unrelated to the like feature we are testing. So we can say, and the next is over trust in output. So this is probably the biggest risk. So sometimes engineers assume that because AI generated this code, it must be correct. But AI doesn't understand our application the way we do. It participate. You can say it predictory code like based on the pattern. It doesn't know our company business rules unless we tell it. So always remember, AI assistant required human validation, not determine. Like you can say, and the another interesting challenge is like a non deterministic behavior. So if you ask AI same question twice, so you may receive two different but equally valid solutions. So neither the we can say neither solution is wrong, but we can uh, but the means is like we can means of the feature, both code run in the same way, but the meaning of that assertions are different. So the fourth is like we can say false and sense of coverage. So this is another trap teams sometimes fail into. AI can generate hundreds of automation tests very quickly, but quantity doesn't always equal to quality. 100 like poorly designed tests provide less value than 20 meaningful tests. So our goal is to minimize the number of tests. Our goal is to maximize the confidence in our application. So so now we are moving towards the next steps. So these four participants have become part of my daily workflow, and I highly recommend to following them like whenever you are using any AI automation. So this is something we need to ensure whenever we are using any AI tool or any using any AI in our automation. So always review before merge, because the first practice is simple. Always review AI generated code before merging it, and treat it exactly the same way you would review a pull request submitted by a junior engineer. Read every assertion, verify every locator, understand every piece of logic, and never merge code simply because it complies. Then the next thing that you need to put in your like keep in your mind whenever you are writing uh, helping with AI or taking help of AI while writing automation code is run against a real environment. The second, we can say, to execute your test against the real application just because Playwright code looks correctly doesn't mean it work in reality. Always validate generated automation against the actual environment. So this help to identify the incorrect assumption before they reach to production. The third practice is writing better prompts. So instead of just saying write a Playwright test, say something like this, like write a Playwright test for an admin user that create a customer, verify the notification, checks the database record, and log out. The additional context produce significantly better results. And finally, like we have versions and review test data. So like it treat generated test data exactly like a production code. Review it, version it, track changes. If your team generates customer records or booking data using AI, those database should still go through the same quality review process as we are using in our production environment. So engineers who learn how to collaborate efficiently with AI will have to able to manage a build better, like they can manage a build better and more reliable and stable automation with the help of AI. They can solve the problem faster and spend more time to meaningful engineering work. So with that we are reaching to the key takeaways. What are the key takeaways or are of our Playwright thing? So whenever we are seeing any kind of uh, AI tool, we are showing that how to use it. And the thing we need to keep in our mind, AI doesn't always replace the QA mindset. So we need to keep this thing in mind. AI is not going to replace a QA engineer. We need to, it is just helping us to accelerate our work. Then we are thinking that MCP is what turned Claude from an advisor into an active participant that can start, test, and verify. Then we can club our all the tools like Jira, Git, Playwright, MCP together and shrink the gap between bug reported and fix verified. Then we can also review the discipline like that matters more. So we can say it will give you less hallucination or junk data in real. So I think we are done with this presentation. So I really appreciate everyone taking the time to join this session and staying with me.